Alright, here's the second part of section 5.2. We're going to continue on with transformations of sine functions. So what are the purposes for today? We are just going to graph sinusoidal functions. Graph a sinusoidal function. Yeah, this is what we're doing. We're just graphing. Continuing from what we did last class, this lesson will be fairly short, more like a recap. So let's graph this big long thing. So if we're giving this cosine, again, we just need to look at all the characteristics. What have we got for A, B, C, and D? And how are we going to use this to graph our function? Midline is at y equals 5, and this is again because D equals 5. The amplitude is 4, because A is 4. From these two things, we can figure out what the max and the minimum values of our graph are. Then we look at our horizontal shift. So C is pi over 4, so I'm going to shift to the right, pi over 4. And the period is going to be 2 pi divided by 3, since we take 2 pi over what the B value is. And from this information, I can figure out I start at pi over 4 at the maximum value. Since it's cosine, the maximum value is at y equals 9. And we are going to finish at 11 pi over 12. Again, that's just from taking C, where we start from, add the full rotation, and we get 11 pi over 12. And then we need to divvy up where our x values are. We split apart our x-axis. What do we get? We need the greatest common factor between C and the period over 4. So in this case, C is pi over 4. The period is 2 pi over 3. So in figuring this out, simplify it down. So I want the greatest common factor of pi over 4 and pi over 16, which is pi over 12. So I split apart my x-axis with pi over 12. Taking all these things, taking the midline, taking the amplitude, taking the max and min, taking the horizontal shift and the period, and splitting up my x-axis, I can now graph this out as following. So you can see we've got a maximum at 9, minimum at 1. The first dot that I drew was at pi over 4, and at the maximum, which is at 9, then I move over p over 4, which is pi over 6. So I go from pi over 4, I add pi over 6. That'll give me 5 pi over 12. I add another one, I get the minimum value. Add it again, I get back to the midline. Add it again, I'm at the max. So you can take some time, pause the screen here, take a look at those points, make sure you know exactly where that is. Again, this is just recap from last class, but I wanted to give you another example from this to kind of help you go through that. Plus, today I'm also going to basically just do a small variety of what I did last class. So first we want to determine the period of two functions. First one is y equals cos 2 pi times x. So if I want the period for this, period is 2 pi over b. The b value is 2 pi, so therefore the period is 1. You can do this again for the b value, or for the second equation here, y equals sine 2 pi over 3 times x. Again, we want the period. We have the exact same equation. So 2 pi divided by 2 pi over 3, and we get that 3 is the period. So here we see periods for radians that are getting it to be nice numbers. We're no longer dealing with a pi as our degrees or the period. We now have whole numbers as the period. And this is going to come handy when we are dealing with word problems, because often we'll say our sprinkler does a full rotation every 15 seconds. So the period is 15 seconds. We need to now know how to translate that into an equation and how to write that out properly. So if we're dealing with real life situations, we rarely see something occurring every 3 pi. So this is kind of a transition period between theoretical sine graphs to practical sine graphs. So that's why I'm going to show you a few more examples with this. So notice if we have equations written as 2 pi over p, so over some number times x, then we have the period is p. So you might notice this in your questions, and you can figure that out pretty straightforward. So let's try graphing a few of these questions. So we've got y equals 2 sine of 2 pi over 4 times t minus 3. Note here I have t instead of x. This is because many sine and cosine functions are a function of time. We refer to time instead of x, or instead of degrees. Because something that is cyclical over time, we need time in the equation. From here, I'm going to do it a little bit quicker with figuring out all these variables. So d equals 0, a equals 2. From that, we can get the maximum and min value. Again, this shouldn't be a surprise. C and P are 4, or C is 3, P is 4. If you need more time to look this up in the equation, you can. So this tells me I start at a 3, and it's at the midline because we're dealing with sine. And it ends at 7 because that is one period after 3. And to break up my x-axis, I need what's the greatest common factor of this. So C is 3, P over 4 is 1. So the greatest common factor is 1. So from all this, we graph. And this is what we get. And take a look at the points. Make sure you see the correlation between what I wrote as your characteristics and plotting this out. And now we have my x values now are some whole numbers instead of involving pi. But this is still in radians. Anytime we deal with a sine or cosine graph with time, it means it's a real-life application of it, which means we are going to deal with time. So the x value for this is now time. It's always in radians. Another note with this, so in this question we had 2 pi over 4 times t minus 3. I can write these out in a variety of ways. I could write it out in front of the bracket, or I can include the bracket inside of the equation. You might get either one of those in there. Also, again, I've mentioned this, I can shift between a sine graph and a cosine graph if I take my, if I shift over instead of shifting to the right to get a sine graph. Notice on the x-axis and the on the y-axis, I'm at a maximum. It's a cosine graph. So the phase shift can shift us from a sine graph to a cosine graph, and I wanted to illustrate that here. Let's try a little bit different type of question. So determine the equation of a sine function where the maximum's at x equals 10, y equals 22, and the minimum is at x equals 18 and y is 12. So from this, let's figure out what the equation is. So max at 22, minimum at 12. So from these two, since we're given the maximum and minimum, let's go cosine. We're not told anything about the midline. Let's just assume cosine and say the maximum point, that is where we're starting from, just to make our lives easier. So that means, well, first let's figure out d. Take the max plus the min, divided by 2, that gives you the midline. We can get the amplitude from this as well. Again, those are just equations I've given you already. This is what I said before. Let's just say we're dealing with cosine. Maximum is where we start, so therefore my phase shift is 10. I'm shifting 10 in the x value or t value, whatever it is in this case. Let's just say that's the phase shift. That'll make our lives easier. The period is 16, and where I get that is if I go from max to minimum and I'm changing 8 in the x direction. Remember, the period is the amount of time it takes to do a full rotation. So I go max to max, that's a full rotation, and that's just double what it is to go from max to min. So my period is 16, that's where I get that from. And the b value is 2 pi over the period. Since the period is 16, b is 2 pi over 16. You can simplify that down to pi over 8 if you want to, I'm just leaving it in this case because this is the type of graph I'm showing you today, is 2 pi over whatever the b value is. So therefore, here is your equation. So y equals 5 cos, and then of 2 pi over 16, x minus 10, all plus 17. So this is the equation that we were to draw, and I graphed it here. You didn't have to graph it, but I wanted to show here that if you look at our points, I have a maximum at 1022 and I have a minimum at 1812. So just to show you that that actually does work, that's not what I was looking for. It was just the equation, but I wanted to prove to you that that is actually the correct answer. So there you go. That's the end of this lesson. I did this shorter, but I wanted to make sure you had a lot of time to work with section 5.2. It's a lot. It's a bunch of information. I wouldn't say it's the hardest section, but you really need to know this to move on to the next part. So I wanted to spend extra time there, and hopefully that all makes sense. All right, so the next movie, one of my favorites. So the description of this one is a handful of people decide to go back in time so that they can save half of the universe. That is the really poor description of this movie. Try and give it a guess. Let me know in class what you think it might be.